Okay. Yes. Hello everyone. So my name is Jatan Rawal, and I'm working as a senior manager in NetSquare Solutions for more than 6 years. As so probably you have heard from Ravi that he's managing the team of 80 plus pen testers and the managers and senior managers. So I'm one of that senior manager report to Ravi. And along with me, I have Kushal Suthar, who is the security analyst, and we both are going to deliver the IoT security assessment and a hands-on training for the firmware analysis. Now, during this entire training, let me share my screen so I can explain you our entire flow. Okay, is my screen visible?
Yep.
Yes. Yep. Great. Now, during this entire training, I'm going to first explain you a IoT security assessment as a pen tester's approach, and what are the ways of doing the pen test on the IoT devices. And then I will talk about one case study that I have done, which is a smart home solution, and how we got the switch control. Then we will have a demo of the switch control. After that, we will have a break, and after the break, we will start one hands-on training on firmware analysis and taking control of the live hosted IoT device. And after the hands-on training, we will also give you one firmware for the analysis for as a self-study, and we'll be there to even guide you during that self-study part. So this is our entire flow for this training. I will now start with the case study. So first, when we talk about the IoT device, uh, yeah, that's my introduction. So I working as a senior manager in Network Solution, and if I talk about the IoT device, so right now the devices which are connected with a Wi-Fi or any other communication module, such as a Bluetooth and the infrared and any other device, and being operated by a microcontroller with running the specific commands which is required to operate the particular device. That is the IoT device, and it is connected to the internet. Now, how the things work? Let's suppose you are having a light bulb, or you are having a tube light, or any other light equipment. That device runs on a power. The power is now controlled by this control unit, which has on board a Wi-Fi module along with a microcontroller and one memory unit where the firmware is stored. Now, what is the standard booting process? That first the firmware will be loaded in the microcontroller. The microcontroller first boots up the extracts the entire firmware. It then tells the Wi-Fi adapter to connect to the router, and based on the router's settings, let's suppose the router is connected and the connection is completed, then it will start broadcasting a packet to the mobile device. And on the mobile device, you will receive a notification that the switch is active. And once you click switch on or switch off, based on that, it will control the switch. Now, it is not only related to the light bulb, but there are multiple devices like even plug. A plug is now also connected to the same kind of the circuit, and it can be controlled over the Wi-Fi. Now, if we talk about the home automation solutions, there are n number of the devices. Let's suppose that we are talking about the microwave, we are talking about even air conditioner, CCTV, gas stove, your dishwasher, TV, coffee making machine, lights, even car details, fridge, washing machine, speaker. All of these things can be connected with to the internet with the use of a single module or adapter, which we say. Even you can do it with your Raspberry Pi also. You just have to control the voltage going to the device. If we talk about any of this equipment, what features it provides to the consumer. the consumer can now connect to this device over the internet from any location. Now, how the consumer will connect to this device? The consumer will first open the app on its laptop and on mobile or on the watch. It is like iWatch or Samsung Galaxy or any watch. If the vendor has created a application supporting the watch, you can also get the controls on the watch and also on the tablet. Now, any of these device will help you to connect to this internet connected devices. You can run the different features. Let's suppose you can run a timer that after this particular time the power will cut off. You can run a timer after this particular time, during this particular time frame the power will be running, so the air conditioner will be running at this time. And you can even set up the temperature in the air conditioner. If you are talking about the CCTV, you can turn it off, you can turn it on, you can do the recording, you can see the recordings. Then for the different devices, let's suppose the light, it is turning on and off. And for the car, we have now the car connectivity features, and you are already familiar with this feature. So moving on to the other devices, it provides the different utilities. Now there is no need to go to the device and click on the board. It is now very easy and convenient for the consumer to just click in the app, it turn it on off and control the utilities such as temperatures, timer and all from the application. Now how this thing is possible? So when I say that this device is first connected to this module and then it is connected to the internet, so it makes it as a smart device, right? So when the device is connected to the internet, then how the user is also getting interacted with the IoT device? So for that there is an application is created. Now what basically this application do, that it takes the input from the user, whether it is on off or the parameters. It first sends that data. It first check whether it is connected on the internet or it is connected on the local network. Let's suppose it is connected to the local network, then it will directly look for the IP address of the device. Now, how it will check the IP address of the device? So, whenever the device gets connected to the Wi-Fi, the moment it connects to the Wi-Fi, it starts sending the broadcast packets. The broadcast packet contains a general information. The general information such as its IP address, its name of the device, and its power state, whether it is on or off. So the application running on your phone will receive these packets from the Wi-Fi and it will check whether the switch is on or off. And it will show you the status of the device, whether it is on or off. Now, when you are outside of the Wi-Fi network, let's suppose you are connecting it through the internet, then the device operates in a different manner. Device first get connected to the router, it sends the data on the cloud server. The cloud server stores the information sent by this particular equipment, and when you open the application, it will fetch the data from the same cloud server and it will have the parameters available of the particular devices. So that's how the thing operates. The user can get connected to this particular devices. Now, what is the usual ideal approach when we are talking about pen testing an IoT device? What is our ideal approach? That let's suppose that it is getting connect. Let's suppose we are talking about a router. Then a router must have a known vulnerabilities like these are the list of CVs, and also there will be number of services which is providing. Let's suppose web application it is hosting, then on the admin portal what kind of the firmware it is hosting, what are the utilities. Let's suppose there is a input parameter on a command page of I just to ping to the other host, whether we are able to inject any other command with that or not. Yesterday what Ravi explained about the XML part, so what things that router also accepting that we can also perform via the web part. Now when we talk about the web application testing, we are more focused on the browser part. But when we are talking about the IoT security assessment, the scenario is divided into different categories. So when we are talking about the IoT security, it can be web application testing, it can be the mobile application testing, it is also covering the cloud testing on which it is hosting, it is also covering the IP testing. The you In network pen testing, we just scan the IP address. So in the same way, we are also scanning the IoT device. In our training, in our hands-on training, we will demonstrate that, and we will also do a practical scenario. So when we are talking about the attack surface on IoT, so it is divided in hardware level, software level, and communication protocol level. So when we are talking about the hardware level, what kind of the circuit it is using, what kind of processor, microcontroller, we are looking at the particular hardware like chip base and the storage unit. These things are first checked on the hardware level. Even Ethernet, USB, this all comes under that. Then software level. In software level, we check related to the firmware part. We do the firmware analysis, we do the firmware extraction, whether an attacker can extract the firmware or not. Then if he is able to extract the firmware, then what is the what is the stored information inside the firmware. So we do that firmware analysis. Even after the firmware part, what is the most critical thing, that is firmware upgradation. How about that we are able to upgrade the firmware or not. Okay, so that is the third thing. Then after the firmware extraction for and all this stuff is done, then there is the last part, is the fuzzing. Are we able to inject anything? Are we able to fuzz the data which is accepted by the application? Now when we are talking about this software part, it on the IoT device, it is related to the firmware. But when it is related to the software of the application Android, then the application which is providing you the way to connect to the IoT device is our target. So the application through which we are connecting to the IoT device is also come under the attack surface of the software level. Even if we are able to hijack that application, that is also a key finding in controlling the IoT device. Now the last one is the communication protocol analysis. When application is communicating to the IoT device, either on the Wi-Fi network or either on the cloud network, we have to check what protocol it is using. Ideally, it is either TCP or the UDP. Now, in depth, if we want to check if the IoT device is hosting a web server and it is hosting the APIs, then our Android or iOS application will send an HTTP request to the IoT device, and it will call the API endpoint with a particular parameter such as the power on or power off, and based on the input it will respond. So if it is going on the HTTP, are we able to do any particular attack on that? Injection attacks, man in the middle attacks. If it is creating a custom packet and it is sending it to the IoT device, are we able to even sniff those data? Are we even able to see what data is going in unencrypted manner, or even are we able to inject something in that TCP packet? So what it what kind of validation it requires is the input validation when it comes for the communication protocol part, that the input validation must be there, whether the injected input is correct or not, valid or not. And the second is the integrity check. When the user sends a data to the switch, is the data modified before it reaches to the switch? So that kind of the validation can be done through the integrity check, that we will see in different case studies. Apart from that, when we talk about the software level part, when I said that firmware can be extracted, and if a user can modify it and upgrade the firmware, then it can also control the IoT device. Now to prevent that, attacker how an attacker can be prevented from upgrading the firmware, and that is via firmware integrity check. When a firmware is uploaded in the IoT device extracts the firmware, okay, and it first check the timestamp and the key parameters of the firmware, whether the firmware is modified or not. It should be ideally identified through this integrity check. If the firmware is extracted and the key parameters are modified, then the firmware is modified without the uh, private key of the vendor. So that firmware at that point should be rejected. So that kind of the key validations should be implemented in the IoT device. So let's start with the hardware level attack. Okay. Um, Before we start the hardware level, is there any question from your end, or even if you are not able to understand any particular point, just you can interrupt me and ask me the question if you have any.
No questions at this point.
Okay, that's great. Uh, so now in the hardware level attack vector. So when we talk about the hardware level, we our target is to check what kind of the access ways available on the circuit. First access way is gaining the share via the debug points. Now, what is the debug point? When we talk about the debug point, it is either the TX and RX pin, which is directly there on the circuit, and second is the memory chip, which if we desolder it and with whether we are able to read the content or not. So if we see in the serial console, so in the serial console, you can sorry, if I open a router and here there are four pins which are directly available on the circuit board, and the pins are usually ground 3v3 or 5v5 and uh, TX and RX pin. Now this TX and RX pin are very important. So what does this TX and RX pin do? These are just serial pins from the directly from the microcontroller. So what it does that whenever you start boot up the router, the entire boot process is also transmitted on this TX pin, and sometimes you are even able to control the router through a shell, and that shell receives the command from this RX pin. So when you are opening this TX pin, let's suppose you want to communicate on the you want to receive whatever is transmitted on the TX pin, then this red wire goes to your RX pin. So their transmission is our reception and our transmission is their reception. So when we are transmitting something from our transmission pin, it should be connected to the RX pin. Okay. So in this way, we are able to see the boot process on our device, and we are then even able to communicate to the serial console. So this is the hardware pins, that directly pins are available on the hardware. Usually now why these pins are available? Now usually this is kept open by the what I say the vendor. The vendor actually keeps this pin for the troubleshooting purpose, because once the circuit is loaded with the equipments, there is no way that you can put a pin. It's not like that we put a debug point in a JavaScript and we are able to check what is the value of the particular parameter. Here we cannot put a direct pin of a multimeter that whether we are receiving the value or not. We have to have a point, certain point, where we can connect our pins of the laptop, and we can connect it via USB, and we can see whether the data going from microcontroller to the other components are correct or not. So that's why these pins are kept in the hardware. Now there are different ways of hiding this pin. Sometimes they segregate these points. Only TX RX are available, ground and 3v3 are not there. Or at some point only TX is available, RX you have to identify, and then you have to connect a very thin and short wire on the RX pin, and you have to connect it directly here. So through the soldering stuff you have to do. So if you have a good hands-on the soldering part, then it is best you can try the hardware level part. No, so this is the first way that where TXRX pin are directly available on the board, and you can directly connect to this device using a USB to UART converter. So when we are connected, what is our target is that we dump the binary file. Why we are dumping the binary file? Because our main target, whenever we are, even doing a network pen test, what is our target? That we have to first identify what operating system it is running, so we can check the file system, how the file system is hosted. Let's suppose if it is Linux, then if we want to inject something, then or call a particular library, then we have an idea ki if it is Linux, then it will be inside this particular location. So if it is running a Windows, then the cmd.exe will be located at this location. So that's why bin file needs to be done, and we can check the content of the bin file, that what kind of file system is hosted inside it. So identify the EEPROM model. So what is this EEPROM? This is read-only memory, which can be, used to store the firmware here. So it is electronically erasable programmable read-only memory, that is EEPROM. So the purpose is to store the firmware. So when there is a hardware which holds kind of this kind of the particular chip, if you can see. So uh, if you are interested in opening the hardware, you can open any device which has the connect internet connectivity feature. You will either find a microcontroller which has directly, a firmware loaded in the microcontroller. If the firmware size is very small, then it is directly loaded in the microcontroller. If the firmware size is larger, around like 8, it can goes up to 2 MB to 8 MB also. So here they use the EEPROM. So in the EEPROM, firmware is stored in a packed manner, and that firmware is extracted on the microcontroller. So what is our target? That we actually find out that where is the firmware stored. When we open any device, we always check for the hard disk and grab the hard disk and try to read it in our device. In the same way, we find out where is the storage unit in an IoT device, whether it is in microcontroller or it is in EEPROM. If it is in EEPROM, connect the pin or desolder the EEPROM. If we are able to connect to the pins of the EEPROM, that is also good. Or if we can desolder the EEPROM and put it on the memory reader, we can directly read the content of the entire EEPROM. So there are some tools available in the market. The first one is the Heartsploit, which supports the number of the EEPROMs, and you can just follow the manual and connect the pins. So here you can see this is the EEPROM, and there are around 8 pins. So these 8 pins are connected with a small pin adapter. These pin adapters are connected over here. So you just follow the instruction on the Heartsploit, and the Heartsploit dump the firmware content. You can also do the firmware dump using the Raspberry Pi. Here what I did is I have used a Raspberry Pi Model 3. You can use any Raspberry Pi because the GPIO pins are available on each type of Raspberry Pi from 0 to Raspberry Pi 4. All models have these GPIO pins. So if you follow the manual of the Raspberry Pi and follow the number of the pins, that on exactly which pin there are pins related to the EEPROM, we run the tool on the Raspberry Pi and we connect these pins on the EEPROM using this. This is also called Pogo pin adapter, Pogo pins. So this pins are connected here, and we dump the firmware content. Now we are looking at a camera, a tri-vision camera, which case study is done by Saumil Shah. Um, our target is to dump the firmware of this tri-vision camera. Now, how will we start? First, we open the hardware of this device. We when we open this hardware, there were two layers of the PCB. The bottom line, and this is the upper side of the hardware. So our target was first to identify exactly which EEPROM contains this particular firmware. So to do that, we either have to, go through each and every component, or we have to identify the TXRX pin and try to gain a share from that. So what we tried first, that let's go for the EEPROM. So when we are talking about the EEPROM, where when we want to extract the content of the firmware, so it is not like that we connect the pins and it just directly starts extracting the content. Once we identify that whether the EEPROM contains the firmware or not, for that we have to read the number. We have to use a binocular and read the number written on this particular chip. We have to search for this data sheet. Now every component such as microcontroller, EEPROM, every component has its own data sheet. Now the what data sheet contains, it is just as like a user manual. For a device we read the manual, it is same. It is data sheet contains all kinds of the information related to this particular component, how the component operates, in which temperature it operates, how you can interact with the component, how to communicate with the component. This kind of this stuff available in the data sheet. The data sheet is released by the vendor and it is available publicly on the internet. It is not kind of a secret stuff. It is actually put on the internet for the developers to read and understand the component. So let's suppose here they have used pin bond, and this is the number of the EEPRO. So what we have to do, we have to search for its data sheet, and we have to search for its data sheet. And here I have connected SOIC8 to clip. Now this is the same clip as this one we are using. Here we have a freedom of connecting an individual pin. Let's suppose if we are able to identify that this pin is connected here, so we can directly connect this pin to the other component and grab the data. So SOIC8 provides a good grip on the connecting to this particular chip. Now we have the data sheet. We know exactly which pins are, what is the purpose of each pin. Now we connect each and every pin to this programmer. Now this is a different programmer. In the entire slides, I will show you the different tools which are available in the market to extract the firmware. So this is the Forte programmer, and these tools are, if you are searching for the tool with a context to dump the firmware or firmware hacking, then I would suggest you don't do that. Only the hard exploit is one tool which is available with that kind of search terms. Whenever you are searching something related to the IoT hacking, it is better you identify the key stuff and search related to the development part. Let's suppose if you want to dump the content of the firmware, then it is better you search like how to read EEPROM and data, and put the number of this EEPROM. Once you identify this number, you download the data sheet, then you search how to upload firmware in this EEPROM with the number. So there will be tutorials available. So as they are also showing you the firmware upload part, you can do firmware modification and upload the firmware in the same way that they are doing. So never search as a hacking search terms, always search as a development, in the development terms. So here this programmer is not actually used to hacking part. It is actually used by the developers to upload the firmware and to also troubleshoot the firmware by downloading from the EEPRO. So what we are using, we are just using this Forte programmer to download the content of this EEPRO. So it will just read the entire content of this file and it will dump in a .bin file. And then that's it. We have the firmware available in a bin file. So that is the one way. The cheaper way, this tool is a costly one. So cheaper way is CS341A. This tool is very cheap and supports limited number of the EEPROM. So when you are ordering this tool, I would suggest you first check on which IoT device you are going to use. First, order that device, tear down the device, check what is the EEPROM number, whether it is supported by this device you are ordering. If it is being supported, then you order it. Otherwise, it is waste of money. So always careful. The tools which you are ordering must support your components. Otherwise, it is uh, gonna create a big interrupt for your testing. So there are different kinds of the bin file programmers available from where you can either upload the firmware or download the firmware from the IoT device. Now, the second is the software level attack vectors. Now, when we talk about the software level, then our target is, sensitive information from the firmware by firmware analysis, then modifying the firmware, and then it is updating the malicious firmware and gaining the share via default password, emulate the firmware. Now, emulate the firmware means you just create a virtual machine of this firmware that you extracted. Then the last is hook the function and understand the logic. Now, before I dive deeper into the software level attacks, any questions in the hardware part? I mean, you can ask anything. No?
Nope, no questions.
Okay, okay,
What
okay.
was the name what was the name of the USB interface for UART? It was in
USB to UART converter. It is called USB to UART, or you can also search as a USB to TTL.
okay.
That is available on the Amazon. USB to UART converter. And uh, okay, this is CH341A. Just before ordering this, just check your EEPROMs whether it supports or not. Sorry, yeah. So here we are on the software level attack vectors. Now, when we start with the software level, so our target is, dump the firmware content. Once we dump the firmware content from the EEPROM, we actually open that bin file either in the hex dump, either we can directly open it in the notepad. Hex dump will give you the hex numbers of each and every byte, and it will also present you the ASCII characters which are visible directly in the bin file. So you can also use the strings command. If you use the strings command, you will have the content of the bin file with all possible ASCII characters, visible ASCII characters in the bin file. So let's suppose that if I'm doing a firmware analysis of a particular switch, then here you can see I just opened that bin file in a notepad plus plus. Now there are n number of the characters and we don't know what is that, but if we just scroll it down and if we know the Wi-Fi name, the SSID, then I just searched that term, and in the same line I was able to see the password stored in the clear text format. Okay, so you can even identify the sensitive information stored inside the firmware, and that is the most one of the most crucial part, that this data storage, how the data is stored inside the firmware. Let's suppose if the device firmware got dumped from an IoT device, and instead of this Wi-Fi ID and password, they have also stored the iCloud API key and username and password for their server, then the attacker can directly communicate to their cloud environment. All right, so the sensitive information must be stored in the encrypted manner. So here when I do the firmware analysis of this switch, I was able to see the SSID, my Wi-Fi SSID and password in clear text. So there is no need to decrypt anything or do any other magic stuff. It was directly visible in the bin file. So let's suppose if I just take out switch from any, or even a smart plug which is directly connected in the switchboard, I just take it out and I tear down the hardware and I dump the firmware content, then I will have his Wi-Fi ID and password directly connect to their Wi-Fi net. I can directly connect to their Wi-Fi network. So this is the one way. Second is modifying of the firmware, updating the malicious firmware. Now, if you are wondering that how someone can modify a firmware, let's suppose if we are talking about a device and we are getting a reason like the device will be hosted in the corporate environment, device will be hosted in the medical environment, and there will be no availability of dumping the firmware or modifying a firmware. They, you will not allow with the tools. Then there are many ways to modify a firmware. What is the purpose behind modifying that firmware? Just a minute. Okay. What is the purpose of modifying the firmware? So if you define that you are able to identify and check inside a firmware, and if you identify a particular condition, if you identify a particular condition which is available at particular line, then you can directly open that bin file in the notepad plus plus, and you can just change that particular character. There is no need of any advanced tool to modify the firmware. Even at some places the hex editor is also allowed. So if you can open that hex editor and you can just change that one byte, the return value is from false, you change it to the true. It was returning 0, now you're changing it to 1. So it is gonna cause an impact in the firmware, and you now upload that particular firmware, and that check is now bypassed. The same thing is also done in the Android testing. That is called Smalley debugging. In Smalley code, you check exactly at where the root detection or root detection is placed, emulator detection is placed. It is either returning true or false. So if it is returning false, if it is returning true, you change it to the false, and that's it. You again pack the application and install it in the Android device. And next time when it checks whether emulator is there or not, ideally it should go true, but now it goes false. So now you are able to bypass it. So that's the same thing also happens in the IoT device, that you can even bypass the integrity check. There is no need to check the entire logic. Just identify the return point from where it is returning the exact value, and you modify it through the notepad, or even if you want to go in a complex way, then there are multiple tools available. The best tool is the IDA Pro, which provides a vast number of utilities, and the second is the Ghidra. So if you can open the Ghidra and the debug the points, you can also identify the logic, and you can modify the logic and then pack the firmware again and install it, and you are able to bypass that particular check. The next one is the emulating the firmware. Now this one is a very interesting part. If you are new to emulation part, and if you want to explore the emulated firmware, then there is a tool called Emux, which is available on the internet. It is designed by Saumil, and this tool has a very good capability of exploring the different emulated firmware, and also it will help you in emulating the particular firmware. If you have extracted the bin file, the user manual of this tool gives you the idea that what other files will be needed to particularly host it inside this environment. It will help you creating a virtual machine, the QMO, and then what is the purpose of emulating a firmware? Let's suppose that we are doing a pen testing of a particular operating system of Windows 7. Then either I will require a Windows 7 machine in the same network with a remote access, so I can understand the services which are running inside it. I can identify what applications are running, or else I will require a virtual machine of the Windows 7, so I can look at the same parameters and all, and the files in the operating system. So what is our main target? That is the control over the operating system. And so we can dig deeper inside the operating system, at which point they are accepting the input, at which point they are validating the input, and at which point the validation is not set, and because of that a vulnerability is vulnerability is there and how to exploit that. If we are, and even exploiting a vulnerability is not an easy thing. In web, we have seen that we have to create the payload based on the error we are receiving from the application server. In the same way, once you emulate, your exploit development process is also a long task where you start identifying how it is handling the input and exactly what point it is breaking and causing a availability issue to the application. So the purpose of the emulating the firmware is gaining control over the operating system so we can dig deeper inside the key libraries. So when we are hooking any function, let's suppose that we identified there are some particular applications. When we are looking at the firmware part, this is the emulating the firmware. But there is another approach that I have shown, that an application which is allowing you to connect from which is allowing you to connect from the mobile to the IoT device, that application is also our part of assessment, because if you can control that application, you can control the equipment. So to hook the functions inside the application, either the application is running on iOS or Android, there are multiple frameworks available, but one of the well-known framework is Frida. So if you get time on hands-on, doing hands-on on the Frida framework, it is really good framework to explore and hook the functions, understand the logic, understand the values, and based on that try to manipulate the parameters of the function and gain control over the switch. Now exactly where this kind of thing helps us, let's suppose the application is running a custom TCP packets. I sniff the data using the Wireshark. Now I'm able to see the packet content, but I'm not able to understand their entire packet detail. I can see there are 16 bytes going on in every packet, but what is the purpose of those 16 bytes? So for that, there are two ways. Either I get access of the IoT device and emulate the firmware and check how the device is handling the input and exactly what functions are disassembling this packet, and then I start noting down the particular bytes requirement from that disassembly function. Or else I get access of the mobile application, either it is iOS or Android. I hook the function which is creating that packet. In that function, if I'm able to get the parameters names before converting it to the hex format, what is the value it is taking, and based on what value it is converting to the hex, so that function can reveal the entire packet disassembly, and use that is only possible through this Frida framework. We hook that function and we check during runtime that how the packets are being created. So hook the function and understand the logic. It is very helpful when you are going for a communication protocol analysis. So when it comes for the communication attack surface, uh, any questions in the software level part? Okay, so just a small recap. What we did, we checked for the hardware related stuff, that what are the accessible ways and what is the purpose of the hardware assessment. Second, we checked is the software level attacks, attack vectors, like looking at the operating system and look the which we call firmware, and also looking at the mobile application through which we can connect to the device. Now we are coming to the middle part of these two devices. The middle way, which is the actual media through which they are communicating. Either it is going through the TCP, either it is going to a particular custom protocol or a standard protocol like a HTTP. The device either communicates on the TCP or UDP. They don't prefer the UDP. UDP is usually preferred for the broadcast packets. Like they are constantly sending the broadcast packet in the network as a status refresh, that a kind of a refresh signal that if the device has missed the power state, then it can receive the broadcast packet and it can understand what is the power, what is the status of the particular device. So in the UDP protocol, there is no acknowledgement from the server or the switch. So they keep on sending the broadcast packet over the UDP. So always look for the UDP packets, because it also provides you the information related to the device. Very general information, but it is a good thing. Now, can anyone explain me from the UDP device what attack surface you can do? Any idea? Let's suppose I get an UDP packet. What will how it will be helpful for me?
Well, it doesn't verify. You can start spoofing IPs and sending information across.
Correct, correct. So if I spoof the IP and as I start sending across the network, the device will understand that either the IoT device has changed the IP, or there is another IoT device which is also showing the same state of the previous device. So it will create a confusion among the application which is hosting it. Oh, okay. We can hear it during our break time. Uh, well, if the UDP packets are, if we are able to sniff that, uh, the application must have a control mechanism, a validation mechanism in place, whether this UDP packet is a genuine packet or not. I'm sorry, I did not acknowledge it properly because UDP doesn't do it. So, uh, okay, so I now got the joke. Then for the TCP part, we get an acknowledgement from the server. Now, mostly the application, the firmware and the Android application or the iOS application rely on the TCP part, because whatever data they send, they must receive an response from the device to show the status, whether the device command ran successfully or not. When we are talking about communication attack surface, communication can be either sniff, then we can perform some injection, either we can perform a fuzzing, and we can replay the packet duplication part, or else we can just sniff it through the MITM. So when we are sniffing something through the Wireshark, uh, we always, uh, if I was there, I would have asked you to perform this particular sniffing attack, because when we are doing a sniffing attack between two devices, usually what we see, that entire packet structure of everything going from one device to the another device. But it is possible because usually whenever you are doing a practice, that the operating system is hosted as a virtual machine inside your host machine. So the entire packets are going, I mean, the Wireshark is having control over that particular network adapter, so it can sniff the packets very easily. But when there is a picture where there are two separate devices hosted in the same network, and you try sniffing those two particular devices, you will not be able to receive even HTTP packets. For that, you have to use the EtherCap, which will perform the ARP poisoning, and through which you will be able to sniff the packet content. What you will just do, that you will change the routing path from device 1 directly to device 2. Instead of that, you will now change the path, the device first send packets to you, and then it goes to the receiver. So I suggest, if you haven't done this kind of the practical work, then must try it. You will not be even able to sniff the HTTP packets. So the MITM attack that I explained, that it is very simple, that you perform the ARP poisoning on the particular device, and you will be able to grab the data of the device 1 to device 2. Now, from here, our case study starts. Our simple case study is that uh, the home equipments are connected with home equipments are the smart plug, smart fan, and the air conditioner, smart AC. These are connected over the internet and being controlled from the mobile application, with either it is working on the Android or the iOS. Now, what will be our attack scenario? If we, talk as a pen tester, what will be our approach? Can anyone suggest? I mean, from where we should start?
I'm not sure the best place to start, but since it has an app, you can tear apart that app. If it has Android, right? You can dig into that. You can look at the traffic that's going across and do that kind of Wireshark capture, and then you can grab the end unit itself and
Yes.
start apart, like you mentioned before.
Yeah, correct. So that will be our first way, that we go through the application, and second is the same for the IoT side. If we can grab the device, we are able to extract the firmware or not. Now, let's suppose you are having a phone, or I would say victim is having a phone. He's sitting in the home, and you do not have access to the Wi-Fi. The only thing you have now in your hand, that smart plug that you have stole from that house, and you are now in your home trying to do the analysis. You only have is the smart plug. Now, what will be the approach? Your end goal is to control the home network. Now, how will we start?
I was thinking, now can you, I guess you want to start seeing what the traffic over is looking like over the wire. I don't know
Okay.
if you, so I did something kind of like that where we got the device and put it on a compromised Wi-Fi network where we could get the packets, right? And see where they were going.
Okay.
But that's the only thing
Okay.
I could think of.
That scenario will not work, because what happens when you take out the switch from the Wi-Fi network, it will keep on trying to connect to the same Wi-Fi. If you click on the reset and you put it in the pairing mode, it will overwrite the ID password. It will not keep it stored. So now what we have is a hardware that we cannot connect to anywhere. So the hardware that we stole from that house, now we have that hardware. So our ideal way, start with understanding that smart switch, that how that smart switch actually works. That first we should observe the hardware details, because we cannot connect it to the internet, because it will override the Wi-Fi details. So without turning it on, we have to tear down that device, we have to open the hardware, we have to dump the firmware, as the firmware stores the sensitive information of the Wi-Fi and passwords that I showed in the previous slides. So we are going to perform the same scenario here. So what we will do, we will extract the firmware from the chip. We will analyze the firmware for the sensitive information, that is the Wi-Fi SSID and the password. After that, once we get the SSID and password, we will get into the network. Once we get into the network, we have two options. The first option is we start sniffing the communication. Ideally, if we go with the lowest hanging fruit, then just understanding the communication through the sniffing is the best way. You just grab the packet, duplicate the packet, and that's it. You are able to control any switch. You just need the packet, the exact command it is sending over the network. Duplicating the communication and controlling the switch. Second is this. Second option is that mobile application, which is the victim is using. You install the same application, you buy a new switch, you check the communication between the switch and that smart plug and the Android application. You create the same packet and send it in the home network of the victim, and you can control the switch. Because how you will get the IP address of the particular device which are there? So through the broadcast packets. Each and every smart plug, smart device, smart switches keep on sending that broadcast packets. So identifying those IoT device will not be a big issue for the attacker, because he is receiving the packets from the network. So first we start with the hardware level part. So what we do, we open the hardware, we try to check what are the ways uh, through which we can communicate. Either we can communicate directly to the CPU, or we can communicate to the serial peripheral interfaces. Even EEPROM is there, or we can download the data sheet and check the communication ways with the CPU. Now this is the switch. This is a There are two switches which I analyze. This is the first switch. Now, can you see any in way through which we can communicate to the CPU?
So anyway, we connect to the CPU. Do you mean like doing the connecting to the individual pins on the EEPROM, like you mentioned before?
Yeah. So here, if you can see, this is one microcontroller. It is ESP8285. This is a microcontroller with Wi-Fi capability. And these are rest of the things are the voltage control related part. And this one is the EEPRO. But there is also one catch available, that is this TX RX pin, which are available on board. So what we have to now do, we have to solder the pins here. This is the back side of the PCB, and this is the front side. If we are able to get these pins, then we just have to pray that the RX pin and TX pin are working. They have not cut the point of this pins. So what we did, we just put the solder heads on this PCB, okay, and then we downloaded one tool. Now, as I told in the hardware part, whenever we are looking at the firmware dump part, never search as a hacking part. We search for a tool called ESP tool. What I exactly search, that upload the firmware in ESP8285. ESP8285. So I got to know about one ESP tool which is available on GitHub, and this tool provide you the communication way to the ESP CPU. So I put the switch in the pairing mode, because I got to know that if once we put it in pairing mode, then we can see the TX and RX pins. The pairing mode is kind of a recovery mode for it. So once I put it in pairing mode, I was able to connect the pins, and I was able to read the details of the particular switch. Now, this is the upgraded version OS, upgraded firmware details. So here we are not able to see the ID password of the Wi-Fi. So I have the two switches. Now in the first switch of a vendor, the older firmware version had that data breach, where in the boot part it shows the ID password which it is trying to connect to the Wi-Fi. So now this one is our bad luck, that we are not able to we are not able to dump anything from this device. So there is another switch I had. What I did, I opened that device, I checked, there are two PCB, one is the bottom part and the upper part. This upper part is actually the Wi-Fi module with a CPU, and you can see this is the EEPROM, and these are the pins of the communication. Now if you can see, this is very short distance, so there are chances that if I put this pin solder heads over here, they might get connected to each other and it can create a short circuit. Okay, so it's a very risky thing. So here comes a magical device called the hot air gun. This is a soldering gun. So that soldering gun starts sending the hot air around 400 degrees Celsius, and it will directly, you just have to point it particularly on the pins. It will melt the solder pins the solder which is connected in the PCB and the pin, it will melt it. You just have to keep on moving the device like this so it don't burn the chip. It is very dangerous thing when we are doing this kind of the workshop. We have to be very meticulous, because if you keep it more than like 2 to 3 seconds, it can burn that particular chip, and it is completely a garbage for us. And if you don't be cautious while doing this, you can also get burned through this hot air. So you just keep on moving the hot air gun on the chip like this, and then it will be removed through a clip, and you can put it in a programmer. This is another programmer, and you can put it in the programmer here. This is the adapter for it, and you put it on this, and then we dump the firmware. We fill the details because we know the number of the chip. We set the chip number here. We select exact which manufacturer and part number is that, and we click on the read, and you click on the read, it will store it in buffer, and then you click on save, and you can then open it in the notepad part, and it is the Wi-Fi password that we have available. So I had two switches which were connected in a home network. Now from the first switch I did not get any ID password, but in the second switch from the firmware, now we are able to retrieve the Wi-Fi ID and password. So once we have the Wi-Fi ID and password, what will be our next step? Our next step is to connect to the network. Without any hesitation, just open the laptop, connect to the Wi-Fi network. Now start the sniffing attack. Now when we are doing the sniffing attack, I told you that this is the ideal communication. It is happening through the router, and to do the sniffing, proper sniffing, we have to do the MITM attack. Now to do the MITM attack, we use the ettercap, and that ettercap will do the ARP poisoning on the victim and the switch. Now both the packets will go through the ettercap, and then we duplicate the same packet either through a burp suit or through a custom script, anything. And if we are able to get the response, then it's the end goal, that we are able to control that switch. So the ghost is inside the room. So what we did, we put the we've selected the IP address of the two devices which are communicating with each other. Then we did the ARP poisoning, and we are able to capture the packet contents. Here we are capturing each and every packet that is communication, that through which these two devices are communicating. You can see the sequence number, device ID. Now this actually shows this starting of the packet, and this is the end of the packet. This is the second packet, and this is the end of the packet, and this is the response coming. So if we can see, the parameters are like sequence, device ID, self API key, the key is there, IV is going on, encryption is true, data. So don't try to deep dive into these packets. Just always first try to duplicate the packet. It doesn't matter whether it is encrypted going in a sequence, or it is going with a flag or something. Just duplicate the packet and check whether you are able to get the same result or not. Here these are number of the parameter, this number of the parameters. If you can see, the encryption is in place. We don't have any value what exactly data is going to the switch, but if I duplicate this packet, it will work. So it is very simple. How we duplicate, we copy paste everything in the burp suit repeater part, and we set up the IP of the IoT device. We send the packet, and done. We are able to get the successful response. We are able to turn on lights off and on from the IoT device. The alternative way is that you hook the FRIDA function. If the application, see here the data is going in HTTP, at some places it will be a custom TCP. So you hook the FRIDA function. Once you sniff the packet, put the same value in the FRIDA function and send it to the IoT device. There is another way. if you are able to sniff the packet content and you don't want to hook the function of the Android application, the Scapy is there. Now the Scapy tool has a network packet. It provides a capability to create a packet through the Python utilities, and it will help you send the packets to any device. So you create a network packet using the Scapy and you start sending it to the IoT device. Okay, any questions in this entire scenario? Because I covered from, zero knowledge of the network, zero knowledge of the target, that how will we control the device, and reach to the end goal of controlling the device. So any question? Yeah,
I have one question. Can we control the hot air gun's temperature?
Yes, we can.
Okay.
So you can set up the temperature like 350, 300, 400,
Okay.
even go up to 600, but it all depends on the melting point of the solder.
Okay.
If you keep it too high, it will melt the solder, but it will also burn the chip.
And my another question is like if the PCB or the circuit doesn't have any written number over there, so how we can identify those numbers
Okay, that's a good
during the
question. Yes,
dumping firmware?
yes, that is a good question. So there are two alternate ways. The first one is the FCC ID. If you can just sometimes look at the back of the device, there are QR codes available. If we scan that QR code, either it contains the app or it contains the entire device details, that what kind of the components it has. Even vendor also shows the particular chip supports for that particular hardware, and through which you can check what kind of the chip is onboarded. Apart from that, if you are able to connect to the TX and RX pin, it will also print the content inside. If you can see, the detecting chip is 8266. Okay, chip is 8285N08. So that will be also printed through the bootman. So you can identify what kind of chip over there. And FCC ID is the best way. If you are able to search the FCC ID written on the device or even backside of the device, if you search that FCC ID on website, it will give you the entire data sheet for each and every component it has on the circuit.
Okay, thank you. Thank you,
Yeah.
Jason.
Yeah. Does anyone else have any question? If you are not able to understand the scenario of reaching from outside of the network to the end goal, I can repeat it if you want to understand any particular part on how we receive that detail. Okay, so I guess nobody has the question, just hoping that you guys understood. Because either we understand everything and there is no question, or we did not understand anything, so there is no question. Okay, so let me just pause the recording also for a minute. Yes, resume. Now I'm gonna hello. W- Wait, was I audible earlier when I was saying?
No.
I'm so sorry. I was keep on switching from one device to the another. So I was saying that I'm gonna keep the mobile camera on, And along with that, I'm also going to do the screen share through which I will show you the MITM attack, the live demo. Now we are going to control the switch from our laptop. The mobile device and the IoT device are in place and we are not touching it. Uh, Now, can anyone tell me the exact steps? I mean, what will be our next step? If we are inside the home network and we know this is the device and this is the IoT which is controlling. Now, how can we sniff their data? I mean, what will be the next step?
So either analyzing the app or trying to capture the traffic.
Yes. Okay. Now we want to capture the traffic, correct? So what tool we will use for the traffic capture? That will be Wireshark, correct?
Sounds great.
Yes. So in Wireshark, I just select this Wi-Fi EN0. And now if you also see in the camera screen and wait, let's share the screen. Yes. Let me know once you see my screen.
Yep.
Done. Great. Thank you. So here we can see n number of the packets are going, right? I mean, if I just now click on the switch, so exactly which packet is going on. Because the constant communication happening inside the entire network, it is tough for us to filter the data. So what is our target? That we have to first identify exactly what are the IP addresses of these two devices. So what we can do, we can first stop here and we can start checking each and every packet and the packet contains and identify what is the communication happening between these two devices. Now if you see, uh, we have to first identify how many devices are there. So for that I will use ettercap. Ettercap will give us a better visibility about what kind of traffic is happening inside the network. We are not poisoning everyone right now, we are just starting the ettercap. And I want to demonstrate what kind of the hosts are in the network. So first we have to identify what hosts are there. If we want the IP address of the mobile and the switch, we have to do a scanning, a small scanning. So what we do, see, this is one IP address, this is another IP address, which are visible. Okay. So what I can do, I can directly just add them to the target, or else I can do a search command. If I do a search command, it will scan the entire range. It will show me the list of the IPC. It got changed because it sniffed the traffic, and whatever IPs were available responding in even going through that traffic, he just captured the IP and show it to us. Now, when I do a scanning, okay, scan for the host, I also have to run the application. So I just click. So now let's look at the results. See, these are the two new IP and this is the third one. Okay, so how can we identify which one is this one? So that will be helpful here in the Wireshark. What I'll do, I will just put IP.ADDR 1.8. So if you can see, it is sending a MDNS request standard query. Okay, what is 1.4 doing? It is there any communication happening between 1.4 and 1.8? No, but this both are sending the MDNS packets. So, at some place, what we can do, either we go through the app or something, but if we are completely blind, then I would suggest let's go with the MITM attack. How about we just put an MITM attack and check whether we are able to sniff the traffic between these two devices or not. So I'll just put this 1.4 in the target one, and I'll put this 1.8 in the target 2. Now I just click on the MITM and then it is ARP poisoning. sniff remote connections. Now I will just view and connections. So do we have any connection? No, not yet. Now what we can do, we can just click in the app, and if both the IPs are correct, then it will directly show me right here. See, the packet is there. I again close. See, another packet is there. Here we go. This is the zero-con switch, sequence, device ID. If we have number of the IPs in the network and we are not sure, then I would suggest we, start poisoning one by one IPs. And there is another way is you do the nmap port scan of each and every IP. Then the switch ports will be visible, and it will be also showing you the details about itself. So you just have to then identify what IP address is communicating to this switch, and that's how you can narrow it down to filter it out, that exactly what are the IPs of the victim and the switch. Now here is the catch. The iter cap will get hang, and I will not be able to copy. So to duplicate this packet, what we have to do, we will require a perp suit. So we can keep it in the repeater, and we can run any time we want, even there if there is no ARP poisoning. So if you can see that these packets are visible here, but if you see that if I set IP address 1.4, this is the entire communication of the switch and the mobile. This is the 1.4, but you cannot see the traffic. Okay, if you can see, it is going on the HTTP, and it is not encrypted because we are able to clearly see it, right? So it is going on HTTP rather than HTTPS. So here there is not at all a single packet captured here right now. Now, as we have did the ARP poisoning, what I'm gonna do, I'll just start it again. Let me just put a filter also. I src host 192.168.1.4. That is our mobile, and we select. And now see now. This is the packet content, right? We are now able to capture the traffic happening between switch and the mobile through the ARP poisoning. Before the ARP poisoning, we did through the iter cap, we were not able to capture. We had that packet capture, and we did not have a single packet capture. Now, if you can see, the entire packet capture is there. If I just click, this is off, and I also have the packet content of it. This is the packet content. Okay, any questions in the sniffing part? Okay, great. So I guess everyone is clear about the sniffing part. The only now the difficult catch is the duplicating it. As soon as I just copy it, the iter cap will hang. So I think let me just stop the MITM. Okay, if I can log packets, import, export it. It got crashed. Great. Sorry for that. There is a buffer overflow in iter cap. Target 2 and ARP. one, on and off. Both packets are here. Don't crash. Okay, allow me some time. I have to find an alternate way just to capture this packet. The only thing that we will not be able to do from Wireshark is this packet snipping, because the headers will not be available. The packet ASCII characters will be there. Okay, again, on, off. Okay, let me do this one. Let me stop this one. Close. Okay, retro. Ah, great. We are able to copy paste it. Just have to check it is not breaking anywhere. Okay, yeah, it is not breaking. Let us now set up the IP. That is 192.168.1.8, and the port is 8081. 8081. Okay, let us see. And okay, this is this is the another packet. Okay, there
I
is
think
some.
JSON format is wrong in but
Yes, yes, yes. One
it's
moment, huh?
required and with curly braces.
Uh, I just have to match with which packet. This Ettercap version is different in macOS. So it's just 1 minute. Those dots are not supposed to be there in every line. Okay, and this is hmm, okay.
PI key is wrong.
PI key is wrong.
It's a wrong. I think in copy paste they
Ah,
modify
okay.
some F to pound
F.
sign.
Okay. Hmm. But anyway, if you can send the details without the API key, I know, and encrypted data must be wrong. I'm sure. Packet to data. This is completely different. And previous one is now new PD. PD. Okay, let's see. This was connection reset. We receive something. Hmm. Hmm. Still here, something is wrong.
And this request, whole post request ending with round
Curly
bracket.
brace. Oh, thanks. And self API key. Ideally, this kind of scenarios doesn't happen when I did this with the Ubuntu. It was working like a charm. You just copy paste it and it will work. Ah, with this.
I think it's because of we copy the data from images. That's
Yes,
only.
correct, correct. Because as soon as I copy it, no, see, I select, now it's gone.
It's kind of UI issue.
Correct. So that's why it is not working. Otherwise, we just send this and we are able to grab the response from the server. That okay. This is interesting. I'm trying from my phone, but okay, wait. I got okay. Okay, now 400. All right, I'll work on it, Ravi bro. Let us have a break of 1 hour. I'll let me just troubleshoot and create the packet, and I will right after the break I will demonstrate the duplication, and then we'll start the hands-on training. Will it be okay?
Yep, sure.
Yeah.
Sounds good.
Okay. So super quick recap. This is the smart switch. This is the input. Output is going to the home switch board, and one of the plug is controlled by this switch. And in this plug, we have connected a light, and this light is actually controlled by this switch, and switch is controlled through the Android application. So here I click. This is on. This is off, on, off. Now let's suppose the attacker has entered into the home network. So now how will the attacker, try to do the control of the switches? So for that, we are going to start this once again. Now, if we have a zero knowledge about the network, then our first target is to identify the IP addresses of the mobile and the switches. So what I do, we start the ettercap. Okay, so there are two IP addresses. This we already identified, so I'm just adding it to the target. If we don't know, then we have to do the ARP poisoning on each of the target and check in the uh, Wireshark what targets are communicating. If you don't know, then you can just click on this scanning part. It will scan and show you the result. Now, currently, you can see there are no IP addresses because there is no traffic going on. So when you click on this search, also click in the application. So when I yes, so when I do this searching, at the same time I also click here. So see, I get these two IP addresses. I add to target 1, I add it to target 2, and I click on ARP poisoning. Okay. Now both these target will send the packets through our system, and instead of just doing this one, now once the ARP poisoning is done, I move here. I set SRC host 1.4, select Wi-Fi, and start the filter. Okay, and now I send a command. Oh, wait, I think filter is not set properly. So this is the packet, HTTP packet, which is going for the on to turn on the switch. So this is our packet content. We copy this, we go to the burp suite, we create a new HTTP request, we just paste it here, and this we write as a this is light on. This is on packet, and target is 192.168.1.8, and that is 8081. Okay, and I create another one. This is light off. I also specify the target. Okay, I just have to paste the packet content for the off, and for that I have to send a packet of off packet. So for that we just wait here. Okay, we go down, and now we click on the switch off. Yes, there, this is our packet of for off. So I follow this HTTP request. Here it is. I copy this, and we go to burp suite again. We paste this, and this is the off request. Now what we do, let me just close this one, stop this packet capture, and just to ensure that we are completely out of this trail, sorry, middleware, I'm stopping this MITM attack. Now this MITM attack is stopped. Let me minimize. And we go to the Bob suit back. This is the on and this is the off. Now this is the phone and we are not touching in the phone, and let's try to send the packet. See, it's on. Let's try to send the off packet. Off.
Cool.
So if you can see, if you read the parameters, see the sequence is there, device ID is there, self API key, IV. Now you can try removing these things, like, you try removing parameters one by one, and you will get to know that exactly what are the parameters, key parameters, which it requires while validating the packet content. So even if you close the entire session, you log out from this application and you still try to send it, it will work. So this is called the packet duplication. So this is the lowest hanging fruit. If you get the communication from a pcap file, just try to duplicate the packet, and that's how you achieve your end goal. This is on and this is off. So any questions in the demo?
I guess that's just assuming most IoT things don't have like anti-replay
Yeah.
security.
Yes. So what kind of the prevention we can set here? Can anyone suggest what kind of prevention should be there to prevent this attack?
Well, it must not have been SSL communications, is what I'm
Yes.
gathering.
Yes, that's one way to secure the communication. That is true. So no one can duplicate, no one can sniff the packets. Correct. Then any other option? Let's suppose this both are working on this SSL certificate and it gets compromised from the server side. That when this particular switch SSL certificate is compromised, now after that we can decrypt the traffic. Now what can be the next step? What will be the next layer that can prevent the duplication attack? Well, the second layer will be the signature. If we can see that in the packets, there are sequence number, device ID, self API key, IV. So this actually sequences, the main thing is the sequence that needs to be, validated on the server, and there should be a key signature in each packet. If we check for the credit card payments, right, in credit card payments, if you have seen the request of the credit card payment, it contains the parameters. Along with it, it also contains one HMAC signature, the signature of the entire packet, that is encrypted with a private key from the payment gateway, and that can be decrypted on the bank's server. So even in between, if you try to modify the packet content, if you try to duplicate the packet content, it will get to know about the modification. So that's kind of a control that you can implement in here, and that layer will prevent the integrity violation related attacks. Okay, so that's it for the demo part. I guess everyone is clear for the practical part. So let me just turn off the camera. And this one. Okay. Well, working with this device is a very dangerous situation. I just had a small short circuit right before the demonstration, so that's why it got little bit delayed. Now I hope everyone has their Kali machines on. If not, then please turn on the Kali VMs, and we are now moving towards the hands-on training for the firmware analysis. We are starting with that. And Kushal, can you upload the IoT Goat firmware? So we are just starting with a publicly available one firmware where we can, practice and dig deeper if even in future. if you want. So Kushal, just upload that IMG file in the Discord channel, so team can download it. So just let me know, everyone, once you start your Kali VM, open one terminal and download that IMG file and put it in your VM machine. Once you do it, just let me know. I'll again start the recording. So this on this IP address, we have hosted this IoT device. Our end goal is to gain a shell of this IoT device. Now, when we do IoT pen test, I always say one thing: it is not about lack of knowledge; it is about lack of confidence. I would suggest always try to look at as a from the different side. It is not an IoT device; it is a single IP address. When there is an IP address, there is IP address assessment. It is just a work of Nmap. Write down this IP address and tell Nmap to scan all the ports and just check what ports are open and what ports are closed. So Nmap will now check all the ports which are exposed on the internet from this IoT device. And meanwhile it scans, we will continue with our task, because Nmaps can take time. So we will continue with the other task. Temporary failure. Invite is now invalid. Oh, okay. So let me just put the IP address here. See, here is the IP address. I will also paste the commands. Currently, I am running. Sorry, this autocorrect feature. So this is the command I'm running right now. Oh wait, it is going to Carson. Sorry. Okay. No need to connect to NSLab VPN. This is the IP address that I dropped. Just try to scan on this IP address. You might not get the ping response because I'm also not getting it. So we have disabled the ping response. This is the Nmap command that I ran. Just open one of the terminal in Kali machine and just start scanning. Let it scan for a while. Okay, Nmap just came back. Yeah, okay, that's okay. If there is no ping, it's fine. Just run this command and it will give you the results of the open ports. And now let me come back to the device. So when you have this device, Nmap is doing its own work. Let me just try to SSH whether SSH port is open or not. So if I just write root at the rate 115.246.28.18, okay, and I press enter. See, it is asking me for the key validation and all. So I just click yes. It is asking me for password. That means the SSH is there. SSH service is running. So now what is our target? Our target is very simple, that we have to get the password of the SSH. We can try some default password. We can use Hydra, we can use Medusa, and different tools. Encrack is also there to crack the SSH passwords. Now there is another way, which is a good option. So let me move to the IoT directory. Okay. So now you will have this IoT image along with you. So if you have downloaded that image, I would suggest you try to extract the image content. To extract the image content, we first have to see what kind of the image it is. So we can use the file command. File command helps us in understanding the metadata of the image file. So what is this image file? This image file contains a wait. This one is the far much difference, and okay. This one is the file command. It is not giving me the too much data, only the size of the sectors and from where it is exactly starting. and what will be the length of the sectors. Apart from that, this is the command which is the bean walk, okay, binary analysis. What we can do, bean walk IoT Raspberry Pi 2.img. Now this one will go through each and every sectors and will tell us that what kind of data it contains. Okay, let me just properly resize it. So yes, everything comes in one line. So it is not kind of, you get every time all the details which are needed. You just have to go through each and every line and try to understand what is the content of the file. So we can see, if we try to just go through the content, what is the purpose of analyzing each sector. Let's suppose you have Windows 7 operating system. What will you do? You will first try to extract its file contents, right? File system, you will try to get the file system, and you will try to look for the sensitive details inside the file system. So this is what we are doing here. We are running a binwalk command. The binwalk command analyze the firmware. It will show us in each sector what is the data available, and if we go through it, and if we go down, what kind of compression it is using. Okay, exe compressed data. If we still keep on going, it has analyzed, and at the last part the file system is squash fs file system compression with xz, and it is in little Indian format. So we have the name of the file system, squash fs. Okay, so we can extract the file using unsquash fs, but better we can the binwalk also provides the utility called binwalk-e, extract the file system from the image. So what we have to give, IoT goat, name of the image file, and -e option, and we just press enter. It will do the entire extraction process, and we will have a extracted file system in our folder. So that's it, done. Now we try to do the ls. Here is the file which is extracted. This is the folder. Hmm. So you can see this is the folder. Now we go inside inside this folder and try to explore the file system, that what is the content of it. Okay, so it contains the squash fs file, xc, and two directories, squash fs root and root 0. Root 0 contains almost nothing interesting, but the squash fs root has number of files, and let us try to dig deeper. Cd squash fs root. So yes, it contains the file system. Now once we have the file system available, we can start going through each and every file and folders which are there. We can use the find command, we can use strings command, we can use locate command, search command, but we have to focus on our end goal. Our end goal is to get the SSH. Now, why are we analyzing a firmware? What is the reason? The reason behind is that if we can, check the etc passwd and shadow file from where we can get the password. Sometimes what vendor does is they keep one of the user along with a hard coded credential, and that password is gonna kill the entire security posture of the IoT device. If they have kept at least one user for the debugging purpose, let's say a developer user is there or a debugging user is there to troubleshoot the issues, and that password is kept inside the firmware, and firmware got released over the internet, and now it is upgraded, it has been pushed on all of the IoT devices. So what we can do, we can just download the image file, we can extract the file system, we try to print the content of the file, and we check what are the users. See, root user is the normal user which will be there in every Linux system. FTP, daemon, nobody, DNS mask, but this is the user. See, IoT goat user, what? in located inside this file. Now let us try to print the shadow file. This is the shadow. See, there is a password for the root user and there is a password for the IoT Goat user. So what we can do now, we can crack the password. These are the hashes. So we can crack these passwords. We can use John to crack the passwords. For that, it will be just etc shadow and word list. Okay. Gabe, did you reach to this point? Let me wait for you. Sorry, I was explaining too fast.
So I got a cat Etsy password, and I didn't have as many users. So I
Okay.
think I might have been in the step above.
Okay.
Because
Did you try cat./etc passwd? Because if you try /etc passwd, it will show your passwd file. Kali
yeah,
Linux machine.
I added that. So I'm in Squash FS root, and I said
Okay.
cat./Etsy password, and my last user is IoT Goat user.
Yes, correct. This is your IoT Goat user. Now just try to print cat etc shadow.
Oh, you know what? It looks good. I didn't see that you had issued a second command there.
Oh, sorry, it's this
We got to get
MacBook.
you. Yeah, we got to get you like oh my ZSH. You can get some color in there.
Yeah, I know. Sorry. So this is the second command that I ran, and this is the output. So you will see one hash file. Sorry, the hash password in the shadow file for the IoT Goat user. Okay, shall I proceed?
Yep, I'm there.
Oh, great. So then we use the tool John and we give it the location of our shadow file /etc. Let me just clear it for you. So yes, then John /etc shadow word list is equal to the location. Now there will be a file. Kushal, did you share the password list file?
Yes.
From the Discord server, you will receive a password list file that is the password list that we are going to use. So let me just show you which file I'm talking about. // yes, it will be passwords.lst. Is it the same, Kushal? LST or .txt?
.lst.
.lst. Okay, so let me just when we password.txt to password.lst. Okay, now password.lst. Now this will be your file. It contains just the number of the passwords. Starting from the alphabet A to all guessable passwords are there. The largest password file is rockq.txt. In rockq.txt, all kinds of passwords are added every day, so it keeps on updating itself. So I would suggest not to use rockq.txt unless and until it's urgent requirement for you, because it will hang your device. It contains n number of the passwords. So we are using another password list which is available in the Kali tool. It is located in the Metasploit framework. So we are using that password list file. Now how to use this one? So let me go back to the IoT Squash FS. Okay, so what we are doing here, we are now cracking the password. We use John Reaper and Along with that, /etc shadow file and -- word list, which is, and then you have to write down the password. You cannot press the tab. If it is supported in Kali, then you can do it. In Mac, it is not supported. So I have to give the entire path, and then you press enter. Once you press enter, if you have already run it, then it will show one password hash, and it will check entire file and will throw the password whichever is correct. But if you have already run it, then it will show only one hash. Otherwise, it will show two hash. If you want to run it again and see the result, just do the thing rm-rf / dot john dot john.pot. Okay, so I just removed the password which is cracked, already cracked by John, and it was stored in cache. So I cleared it and I run this again. So see, loaded two password hashes with two different salts. So now it will crack the password. What is it basically doing? It is creating the MD5 crypt of each and every password from this word list and matching it with the hash of the shadow file. So here is the password cracked, and this is our user. Okay, so okay, Gabe, are you able to follow? Did you crack the password?
I think my syntax was off. I need to put an equal sign after word list.
Yes, yes.
Yeah, because it made it look like it uploaded them from Shadow and then it didn't do anything, but it didn't really let me know.
This is the command, and after the equal to, you can just give the location. I would suggest you put the password list file in the same folder where you are right now in the terminal. You must be inside the squash fs root, so you can put the password.lst file right in that directory, and then you just give the word list as a /password.lst, and it will run.
Okay, I got it. I got the IoT Goat user.
Oh, great, great, great. Thanks. So now what is the next step? Just copy this command and SSH IoT goat user @ our IP address, which was 115. Yes, this is the IP, and we copy the password and enter. See, we are inside the network. This is the IP address of the IoT device. So what exact vulnerability we exploited? Can anyone tell me?
Say that again.
What exact vulnerability we exploited here? Okay, so if we are able to log in with default password. Now, how we crack the password? How is it a default password? So whenever you will download this image file from the vendor site, it will contain the same password. And just to crack the password, you run the John the Ripper, and with from the known password, it will be available. The hash will be cracked. So the main thing is the hard-coded credential is there, and it is a default password which we have used directly in the SSH. There is no vulnerability in SSH. The only vulnerability relies is the hard-coded credential. They should have removed the password and user IoT goat user before releasing this VM. If a vendor is supposed to release the VM publicly, then he must remove all default user and debugging users from the app, image file, from the bin file. So no one can utilize that or take a leverage of those users. Okay. So, Gabe, did you get the SSH connection?
No, I got that it's trying to do a RSA connection that it wants a cert.
Yes. Yes. Right now, yes. Once you shows RSA part, there will be an option of yes or no. Just write yes and enter. It will ask for the
killing me right
password.
away. It's
Okay,
saying unable to negotiate.
Yeah, I have exit from the connection. Now try it once again.
Oh. It's still set up, but hang on.
Okay.
It's still saying unable to negotiate. 115, 246, 2818. Can you hit your up arrow? Can you show me your SSH command? Just double checking that.
Yep, this is the one.
IOT code. Yeah, it's still trying to do an RSA. Key share. If I don't specify user app. No, it didn't work. I'm not sure why it's not letting me.
Kushal, are you able to do the SSH?
Just a minute. I can check.
And apart from that, anyone who has Windows device, they can also do the SSH on this IP. I have pasted it in the Zoom chat. Can anyone else try? I want to see, is it the issue from the remote location? There is no need to check it from Kali machine. You can just directly do the SSH from your main host machine.
Bro, same error.
Same
Unable to
error.
negotiate with
Let me try it from my
422.
Mac.
Unable to negotiate?
Unable to negotiate with IP and port 22. No matching host key type found there for SSH RSA.
Yeah, I get the same error.
Oh, okay.
Now, is the known hosts file in the file system? Oh, never mind.
Kushal, send me the screenshot of your error. I want to see that.
Sure, just a minute.
Seems to work for me from Windows.
It worked for from Windows?
Yeah, I didn't get a error.
Okay, so you are able to log in. Shall I drop the password in the chat?
Sure.
This is the password that we cracked. One moment. Okay. Yeah.
Yeah, I
we-
was able to log in.
Perfect. I think Kushal, in Kali machine we have to enable the SSH change the SSH configuration. Our Kali machine. Wait, our own. Let me
Yeah.
see.
I got the same error on my Mac going,
Okay.
so I don't know what's up there.
Yeah, I think it's something with the Kali machines. I successfully connected and logged in from my Windows workstation.
Yeah, okay. Okay, so what this showing me the resolution is Okay, you can also add SSH. We have to open the SSH config file in our own config file. Kushal, are you there?
Yes, I can.
Kushal, can you share the screen? Let me just pause the recording here. This inside this IoT device, what kind of the sensitive files apart from the etc pass WD and shadow?
Maybe a database or something.
Absolutely right. So let's start with the database part. Kushal, try the find command. Find space dot slash space hyphen name space star dot db. Remove the double quote. There is no need to put the double quote. And at the end, put the option hyphen capital R. Yes. Wait. What is the error? Can you go up? Is it related to hyphen R? Yeah, it is related to hyphen R. It is busy box, no? Okay, that's fine. Just remove the hyphen R. Just press enter. Are we able to get it? No, because hyphen R is necessary. So what you can do, Kushal, go back to your left side's window in your Kali machine. Let's come out of the SSH and go back to your Kali part. And here in this squash fs root, increase the font size. Thank you. Come out of the etc part. Just stay inside the squash fs root. That's it. Okay, now paste the same command here. Star.db space hyphen r, capital R. No. Okay, remove the hyphen R. I don't think so. It will show the result. It shows okay. Lib firmware regulatory.
This one is a different.
Okay. Not in this one, Kushal. Go to the IoT.
Just a minute.
Good. Okay. Okay, before you run the command, clear the screen. It is to, yeah, thanks. Okay, now let's follow the command, find command, press enter. See. So Gabe, are you able to just put that command in the chat, Kushal?
Sure.
We need to run this command from our Kali terminal, not in that SSH terminal, in the Kali terminal. Are you able to see the results that is shown on the screen?
So you did that on the extracted file, right?
Yes, in the
From
extracted
the
file.
image. Okay.
Did you get the results?
Having problems with my virtualization here, but slowly.
Okay, let's wait. Rest of the people, you can also try the same command from your Windows SSH. The only limitation you will face is this recursive mode. When you use the find command, if the recursive mode is supported, then you will be able to see the other, these files inside the subdirectories. Otherwise, it will just check the existing directory and it will try to print the results of the same directory. It will not check the subdirectories. So try to look for this if you can find it. Otherwise, just wait till the Gabe enters the command and gets the result.
Okay, I found the 2 files.
Ah, great. Okay. All right, Kushal. Now let's connect to this database. So this is the DB file. In Kali, we have the inbuilt feature that is called SQLite 3. So Kushal, use the SQLite 3 to connect to this database. SQLite 3 space this path, the first file, sensor data. Just copy paste it, no? Thanks. Okay, now show tables. Yes. Wait, not the semicolon. Show database. Sorry. First, we have to select the database. Show database. Semicolon. Yes. Okay.
Jatan bhai.
Yes. What is that? Dot databases. Okay. Okay. Just one moment. Then after once the dot databases is done, now show tables. So is it the dot tables? Keep on pasting the commands in the channel, huh? In the group chat.
Sure.
Also checking in my terminal, just for a minute. Should get connected. Okay. Uh, just write dump dot dump. Yes. So what is the content? We can see the table is sensors, right?
Yeah,
Sensors table is there. So try that command that you are typing. So that is select star from sensor, enter.
Sensor.
Because that table does not contain any details. Now, okay. But here we have the details available, which is shown on the upper one. That is the sensitive information disclosure, where we can see the email IDs of the employees, birth date, right? Their birth date. So those are the sensitive details which are not stored in the encrypted manner. That this table ideally should be removed and it should be created with some static value, not the details of the employees. So this is one of the part for the storage related. Now, did we get the results yet in my nmap? What is the time? It is 66% done. Okay.
So the dot dump has all the transactions.
Yes, so that will dump the query, the uh, create table sensors, and you can go through that. What are the sensitive details mentioned inside the database file? Okay. Apart from that, in our search connection, Kushal, are you able to access the SSH? Mine got stuck. I'm not able to print anything inside.
I'm already in SSH.
Oh, okay. Your SSH is okay. Broken pipe. Yes, I got it. Okay. Now, okay. Apart from that, let's go to the SSH service. Now, as inside the SSH console, try the command netstate, netstat space hyphen antp, antp. Yep, press enter. Great. So we can see there are ports which are exposed on the internet 0.0.0. So there is 22, 443, 53, 80, and 5515. Okay, let us try port number 80. Uh, Kushal, open a browser and try the same. So we have already dropped the you sorry, IP address, not did not drop the URL. So let me just drop it, gw.lab.ns that exploit lab.net. So this is the URL you can open in your browser and just yeah, Kushal, copy paste it, press enter. gw.lab.ns.exploitlab.net. It is the correct man. What happened? I Yes, I have forwarded. Okay. So HTTPS we have to paste. Kushal, the only limited ports are exposed. So try HTTPS // Great. Just paste that URL. So this is a website running on this one. So do we have any other way? Now we do not have the password of the root and this password. So Kushal, try the IoT Goat user and password. Are we able to log in? Okay. So it requires the root username and password. Okay. So for root username password, we have to crack the password from the word list. And here the when the yes, Kushal.
Sorry?
Did you say something?
No.
Oh, okay, okay, sorry. So here we can try is the Derby to check any other hidden files, or if there are any hidden files on this IoT device. So we can use the find command inside the squash fs terminal, Kushal. We can go back. We can search like the DB files. Yep. Here instead in find command star.htm. These are the HTML files. So I guess HTM should be there. HTM, HTM, HTML only one. So just try HTM. See, these are the files. Just let's look at the files one by one. Here, add value, firewall, value. Okay, okay. NS inspection. Net info, compound and value. Okay. Okay. Admin. Uh, admin status, admin message wireless, admin. What is this cmd.htm? The second last. Can we directly access this page? That after LUCI, copy after LUCI, I guess it is there. Rest of the path is already there. So yes, after LUCI, yeah, see, slash paste. It is 404. Do we have any error? Double slash is there. Okay. Is it an admin directory or something? Is there any directory we missing? Can you just check the path again?
Yes.
Okay. You see view. Okay, so there is no admin mention. Go up. Do we have any other in juicy value that can help us? Start from the beginning. Okay. Go to this directory, Kushal. User lib lua luci. I want to see what folders are there. Okay. Now okay. Okay, is there a folder of where www cd space slash where slash www? Usually the files are hosted also.
I think it's web CMD is where it's hosted.
Okay,
I think.
okay. We shall try slash where. Gabe, can you paste that command in the chat? The location
Well, I
slash.
was just looking at that actual file.
Uh-huh.
It looks like there's this build URL method that's invoked, and
Okay.
it's I believe what it's saying is the resource is called web CMD instead of like command.htm,
Mm-hmm.
but I'm not certain. Thought it was worth a shot.
Okay, Kushal, try to see the source code of the cmd.htm. Just print cat command of that cmd.htm file, the entire path, cat command.
Sorry, say again.
No, wait. You stop the screen share, Kushal. I'll do the screen share.
Okay.
Yeah, thanks. Okay, so I am inside this. This again got stuck. Okay. Let me just give it a minute. Yeah, it is back. Oh, okay. So we are still in terminal. Great. Sorry. So what was the location of the file? That was get.user. Kushal, can you drop that location? The
Sure.
cmd.htm file location.
Just a minute. Just a minute. Okay. I'll just check chats.
Perfect. Thanks. So what is inside this file? Let us just look at this one. Oh, sorry. cd underscore IOT cd squash with. Yes. So cat. Okay. So this is our page content. Okay. From here it is starting. This one is much better. Okay. Okay. It is creating an XHR request. It is calling admin IoT goat web CMD x.response. Okay. Data console x.
So I guess we still don't know where this page is at, but if it looks like we can get to the page.
Okay. So if I think I know. 1 minute. https:// show details, visit website.
Visit the website.
Method is implemented by the server. Wait.
Check chat. Chat में मैंने URL रखी.
Oh, sorry. My bad. https://gw.lab. Yes, this is the correct one, right? So what is the location? LUCI. LUCI view IoT code cmd.htm. Okay. The another one is the camera, no? What was the name in the same file? Okay. Camera.html, no?
IoT code.
Camera.html and door.html. Let's try all of this. Placeholder and footer. Okay. What does this have? Door.html, placeholder, footer. Okay. So only the camera has the details, and that is admin. It is creating an XHR request, admin, IoT GOAT, and web CMD function X response. Okay. Get element by ID result. Okay. Okay, so it is creating an XHR request. How about build URL admin? How about I directly put
So I got a
this
403 back from it.
admin? Okay, just 1 minute. So I just try this as a admin and CM. What do we have? Okay.
Oh, you're on the box.
I'm in the box. So thanks. Picto.lua dispatcher. Okay. Okay.
I saw a www there, so you might just be.
No, I think it has to be. Let's do something. View. Okay. What does the cat command do for this one? We have, I guess. Okay. Okay. BGI pin slash. We have anything in the config file ls/etc. Do we have something like HTTPD service? Config is a directory. Okay. DHCP ls. Okay. HTTPD. Okay. Cat /etc config u HTTPD. Okay. What if we traffic from /etc config UHTTPD.
Bro,
Answer for 443. Option home is www. Yes.
I'll try this one.
Okay, CGI win. Yeah. Okay, admin IoT. How did you find that one?
Just a code.
Okay.
Yeah, I had gone to that one. Oh, but not command
Yes.
inject.
Oh, perfect. Okay. Okay. I'm still not able to reach that. Kushal, are you able to reach that location?
No.
So that was the one I was telling you I got the 403 on.
Okay. So actually, what I was trying to do that we have to check each and every page those are hosted, and let's look at those page if we are able to get any access of any one of this page. If we can get access, then it is an unauthenticated access to this page, and the lack of authentication can lead to it. So usually, uh, ideally it should get some access, but that is okay if we are not able to do it. So that was the time allocated for it. Now let's see if my Nmap scanning. Ah, my Nmap scanning has returned. Okay. So 422 we have tried, 443 we saw, 1337 waste. Okay, 51. Okay, this one is unknown. Then 31337 elite. Okay, so let's try with this 5515. Why? Because I can show you net state hyphen ANTP. So let's see what ports are open from here inside. So 5515 is open, 80, 53, 22, 443. Rest of the ports are not exposed. So when we see this IP address list, the open ports is 5515 is matching, 443 is matching, 22 is matching. These three ports are exposed from directly straight from our IoT device. So what is hosted on this device? 5515. We know that this is SSH. We know this one is 443 is the HTTPS service, and 5515 we don't know. So let's try connecting to this one. So that's why I ran the command with -p hyphen so it can scan all of the 65,000 ports. It took around 1 hour, I guess. But it gave me, yeah, it gave me all the ports which are available. So I run nc-nv, the IP address, and 5515, this port. Successfully connected to IoT GOAT's backdoor. So a backdoor is set by the vendor team to troubleshoot something or to take access and identify what is the root cause behind any error they are facing. Okay, so this is the backdoor, and ideally a backdoor is always a root. So yeah, here we are. We have the root access, unauthenticated root access, that is root shell that is available in the IoT device. So this should not be there. Actually, this port should be closed and the service must be removed. So if we check if config, yeah, it is working. Gabe, are you able to do it? Even the people who are working from the Windows machine, they can directly connect to this one. They can use the telnet. If I understand, then telnet will also work for them. So this is the unauthenticated backdoor access. So yes, Gabe, are you able to access it? Let me just drop the command in the chat.
Yeah, I'm in.
Yeah, see, so there is no authentication needed. So if we have run the nmap properly with the -p hyphen and we just check all of these ports one by one, then we will get the direct backdoor access. So without doing any image analysis or a firmware analysis, cracking the password, we can directly gain access of the device, the root shell. So this actually, if we think that it is not possible, this cannot be possible in the real time scenario, but it is actually possible. This is just a developer's mistake. They forgot to, just close the service and remove it from before going on the production. And when did this thing happen? When there is no automation in place. If there is an automation in place, so, there are certain checks which are run by the script, so it can be covered. If it is done manually, then it all depends on the developer. If the developer forget about this, checking about this configuration, then it can cause disaster to the vendor team. Imagine a scenario where this image is not the image, this IoT firmware is upgraded in all of the IoT devices which vendor has released, and the backdoor is available on all of this. So that kind of thing can cause a disaster for the vendor team. Okay, so what we learn from this, that is the insecure network services. As per the standard vulnerability name, then it is an insecure network services. Ideally, this service should be closed and removed from the operating system, and only 443 and 22 should be in place, and 22 should be allowed only and only if it is in recovery mode. Otherwise 22 we also recommend that it should be disabled. Only the 443 should be exposed. But if you can see here the internal services, so if you are in the network of this IoT device, then you can access the rest of these ports also. So why are we not able to see this port number 80 and 53? Because either the 53 did not respond during the nmap, so that's why we are not able to see that. But for 80 number, we were not even able to connect it through the browser, because so that means that port is not exposed on the internet. It is exposed only to the internal network. All right. So these are the connections that we have received from the different users for on the port number 22 for the SSH. Okay, so this is it. This is for our IoT training part, where we did the firmware analysis. We cracked the password, get the sensitive information, gaining backdoor access, checking the storage. We also did the storage analysis. Okay, so that's all. Now what we have is another bin file that Kushal, can you share that in the Discord channel, or can you share the link with them? It is the same kind of scenario, only do the firmware analysis. I'm giving 15 minutes for this. During this 15 minutes, if you are stuck somewhere, I would suggest you do the Google. And yeah, Gabe, you can, if does anyone also gonna go on break? I guess we can take a short break of 10 minutes. Will it be okay?
Okay.
All right. So let's see you after 10 minutes.